Hey there students, it's Miss Adams, and in this video we're going to learn about solving equations with variables on both sides. Alright, so our first example, solving an equation with a variable on both sides. I have 10 minus 4x equals negative 9x. I'm going to draw my line down the equal sign. If you notice, I have an x term on the left side of the equal sign and an x term on the right side of the equal sign. So I'm going to try to get the x terms to one side. I'm going to move the minus 4x to the other side by adding 4x on both sides. And then I'm left with 10 equals negative 5x. Now I can solve for x by dividing both sides by negative 5. And I get x equals negative 2. All right, our next one, I'm going to draw my line down the equal sign. I have 5p equals 24 minus 3p. I'm going to move the 3p to the other side to get the p's together on one side. Because it's connected by a minus, I'm going to add 3p to both sides. And that's going to give me 8p equals 24. I want to get p by itself, so I'm going to do division, divide out the 8's, and I get p equals 3. All right, another example, solving an equation with grouping symbols. All right, we're going to separate our parts of the equation. I'm going to go ahead and distribute the 3 and distribute the 1/4. So 3 times 3x is 9x. 3 times negative 4 is negative 12. 1/4 times 32 is 8x. 1/4 times 24 is 6. Then I'm going to move the x's together. I like to move the smaller one. So I'm going to move the 8x by subtracting 8x on both sides. All right, that's gone. I get 1x minus 12 equals 6. I'm going to move the 12 to try to get x by itself by adding 12 to both sides. I get 1x, or just x, equals 18. And 4. I'm going to distribute the 2 and distribute the 0.5. 2 times 3n is 6n. 2 times negative 4 is negative 8. 0.5 times 10 is 5. And 0.5 times n would be 0.5n. And we're bringing it down with the minus there. I'm going to combine my n terms. So I'm going to move the minus 0.5n to the other side by adding 0.5n. I'm going to get 6.5n minus 8 equals 5. I want to get n by itself, so I'm going to get rid of the minus 8 by adding 8. That's going to give me 6.5n equals 13. Divide both sides by 6.5, and I get n equals 2. All right. One solution, infinite solutions, and no solution. So these are some different possibilities. When you have a variable on both sides, sometimes it will never work or always work, or it only works for one value of x. All right, so we're going to solve these and see which ones we have. So we distribute the 3. That's going to give us 3 times 5x is 15x. 3 times 2 is 6. Bring down the other 15x. I'm going to try to get x's on one side. I'm going to subtract 15x, and it cancels both sides. So I'm left with 6 equals 0, which is not a true statement, so this has no solution. All right, the next one, I have x over 6 equals negative x over 6 plus 1/2. All right, so I'm going to add x over 6 to the other side to get rid of the negative x over 6. That one cancels. X over 6 plus x over 6 gives me 2x over 6 equals 1/2. I'm going to try to solve for x, so I could multiply by the reciprocal, or I could multiply by 6 and then divide by 2. All right, the 6's cancel, the 2's cancel. I'm left with x equals, multiplying fractions, no big problem, top times top over bottom times bottom. I get 6/4, which could also be simplified to 1.5 or 3/2. All right, that has one solution. The next one, I'm going to distribute the negative 2. That's going to give me negative 8x minus 2 equals negative 8y minus 2. If I add the 2's to both sides, they cancel. I just get negative 8y equals negative 8y, which is true. Or I could try adding the 8y to both sides, and the y terms would cancel, and I'd be left with -2 equals -2, which is also true. So if I get a completely true statement where the things are equal, then I am going to have infinite solutions. All right, modeling real life. A boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to current. How far does the boat travel upstream? All right, so distance upstream is equal to the distance downstream. The distance it's traveling is the same, but the speed is different. We're going to let x equal the speed in miles per hour. So x times 4 hours. So a boat leaves New Orleans and travels upstream on the Mississippi for 4 hours. So it's going whatever speed it's going for 4 hours. The return trip only takes 2.8 hours, but the boat travels 3 miles per hour faster. So whatever speed plus 3 miles per hour times 2.8. And the distance it's going has to be the same, so I'm setting those equal to each other. And then I'm going to get 4x when I multiply equals, when I distribute the 2.8, 2.8x plus 8.4. Now that does look a little different because I'm distributing it from the other side. You could write the 2.8 first and put it in front. All right, I'm going to subtract 2.8x to get the x terms on the same side. That cancels out. I get 1.2x equals 8.4. I'm going to divide by 1.2, and I get x equals 7. So the boat travels 7 miles per hour and travels 4 hours. All right, so they're traveling 7 miles per hour when they are going upstream. And then 10 miles per hour when they're going downstream because they have the 3 extra miles per hour. You bike for 3 hours to reach the beach. Using the same route, the return trip only takes 2.5 hours because you travel 2 miles per hour faster. How far do you bike to the beach? So, so the boat travels 7 miles per hour and it travels for 4 hours going upstream. And we want to know how far does the boat travel upstream? So the distance. So 28 miles is how far they go because 7 times 4 is 28. All right, you bike for 3 hours and reach the beach. Using the same route, the return trip only takes 2.5 hours because you travel 2 miles per hour faster. How far do you bike to the beach? So the distance, again, is the same. The distance to the beach is the same as the distance from the beach. But we're going to let x represent the speed in miles per hour that you bike to the beach. So it takes you 3 hours to get to the beach. So your speed times 3 hours is going to tell us the distance. The speed, I'm going 2 miles per hour faster on the way back home. So x plus 2, and that only takes 2.5 hours. So times 2.5. I'm going to distribute that 2.5. X times 3 is 3x. X times 2.5 is 2.5x. 2 times 2.5 is 5. And then I'm going to try to get the x's on the same side by subtracting 2.5x on both sides. That's going to eliminate. I'm going to get 0.5x equals 5. Divide by 0.5. And I get x equals 10. So x was the miles per hour on the way to the beach. It took you 3 hours to get to the beach. So the distance must be 30 miles to get to the beach because 10 times 3 is 30. All right, I'll see you next time.